Howdy, everybody. Hope you're doing well wherever, whenever you are. We're here for day 5 of Advent to Code in the year 2016. Well, the year we're doing is 2016. Anyway, today, the 2016 has been going on pretty well so far. I feel like I haven't had any tough problems that I haven't been able to solve. So yeah, let's just get to it. This one is, how about a nice game of chess? You're faced with a security door designed by the Easter Bunny engineers that seem to have acquired most of their security knowledge by watching hacking movies. What is that a link to? War Games? Okay. That is a great movie. The 8-character password for the door is generated 1 character at a time by finding the MD5 hash of some door ID, your puzzle input, and an increasing integer index starting with 0. A hash indicates the next character in the password if its hexadecimal representation starts with 5. Have we done this before? Am I on the right year? Yeah. Okay. Oh, maybe it was for something different. This sounds really familiar though. 2016. Okay. Sorry. If it does, the 6th character in the hash is the next character of the password. For example, if the door ID is ABC, the first index which produces the hash that starts with 5 zeros is this number. So 3 million, which we find by hashing this. The 6th character of the hash, thus the first character after the password, is 1. This one produces the next interesting hash, which has an 8. The 3rd produces an F. In this example, after continuing the search a total of 8 times, the password is this. Given the actual door ID, what is the password? I think this is different. So yeah, it's there must just have been a previous day that we've done that used this same thing. I gotta go look back though, because I probably want to use the same crate. But yeah, okay. There you go. So for part 1, I mean, the thing about using hashes like MD5s is like there's no real way to like skip ahead or do some kind of solving, at least as far as I know. So like what you kind of have to do is just try each one, and I think you can probably parallelize it if we need to. But let's go look first of all. Do we have something that does MD5? Yeah, we do. Day 4 uses MD5. Okay. I mean, I'm probably going to do the same thing. Just do create a hasher, update the hasher, and then iterate. Okay, it does look like I use a parallel iter by exponential blocks find first. I can probably do the same thing. What was this? This was used to find like the first 5. Oh, the first N. Which is this right here. Maybe I won't do this part this time, but still do something along these. How many did it say we needed? We needed 8 times. So we can like basically do an iter and then do a find. For the first 8 based on our puzzle input. Where does MD5 come from? MD-5. So we add this to this, no, to this one. And then we can go to this one and copy this stuff. We'll see. Then we can go in here. We'll paste it in here for now, because we'll probably be using it. So what does our input look like then? Oh, it's literally just a single string. Like that. Just probably trim it of any new lines or anything. Okay, and so then I think we just want to do this stuff right here, right? So, but we're not going to return a usize though. We should return a string. Hmm. 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 And then, so we'll do something inside the find first, but is there another like, does it not like that I have like a, oh, I didn't. I hadn't saved. Why doesn't it like this? Isn't there, maybe I go back to that day 4. This. That's what I was missing. Yeah, I don't know if I want to like maybe we try it without Rayon first? So it's like we call filter. Is it filter map? There's probably a hex library we need to add, huh? Sorry, I'm just looking for this MD5 library. It probably has an example of how to use it. Hex literal. So we probably want to do that too. So we do that, and then we can do oh wait, maybe this is not, maybe I want to do it the other way. I want to do it the other way. How do I dehexify? Oh, I probably just do it in yeah, this :x. In code. So it's not hex literal, it's let's see. Rust hex. Okay, I mean it does say do this, so oh, what is this? Oh, it's a trait. So if results those are equal, then we return sum results 6. Otherwise, we return None. Okay, so it doesn't like that part. Can't compare stir with stir. What is nth? Needless borrow, okay. And then we can, so now presumably we have this, and now we can do dot take 6 dot collect, something like that. I mean, it takes 2 seconds to run. Let's just see if it's correct first. Oh, it's not even the right answer. Ooh, is it because the nth? Should this be 5? Oh, it's gonna make me wait. What was that? Way that I did that? By exponential blocks. Into par iter by exponent. Ragon. Filter map is not an iterator. So it's saying exponential block iter is not an iterator. So maybe it doesn't work doing it this way. It's just really slow, right? Nope, not. It wasn't that. This. Let's just see if we got it right. Still not the right answer. What the? 1, 2, 3, 4, 5, 6. Oh, I'm only doing take 6. Right? How many did it want? 8. I was like, those definitely seem right. Three seconds, though, is really slow. Okay. I mean, we got there. Let's move on to part 2, I guess. I definitely think we want to optimize it, but we'll see. As the door slides open, you're presented with a second door that uses a slightly more inspired security mechanism. Clearly unimpressed by the last version. In what movie is the password decrypted in order? Okay. The Easter Bunny, and oh, that's because in the war games, if you go to the end, it's like trying to figure out what the password is. Instead of simply filling in the password from left to right, the hash now indicates the position within the password to fill. You still look for hashes that begin with 5 zeros. However, now take the 6th character to represent the position, 0 to 7, and the 7th character is the character to put in that position. A hash result of this means that F is the 2nd character in the password. Use only the first result for each position and ignore invalid positions. So I'm going to get some number here. It needs to be between 0 and 7. And if I have already seen that number, I don't get it again. I shouldn't override it. But then it means that this one is the one. So it just means I'm going to do like even more hashing to find the right values, but I had to like build the loop to do that. For example, if the door ID is ABC, the first interesting hash is from this, which produces 1, 5. So put the 5 there. Yeah, so we're basically just, we have this password that's 8 digits, position 0 to 7, and the hashes now give us values. So like that first one is actually not valid because it gives me a D for the first character, so I would ignore that one. Yeah, that's what it's saying. Okay. Well, this is going to be slow unless I figure out how to do this type of thing. Okay, well, let's at least start with this. And I think we need to turn this into a for loop. And we'll say like let password equal vec 8 like that, and then we're going to return a string, so we'll have it be when we're done. Oops. Like that. I'm going to take the 5th one. We can clean this up later. How do I want to do this? Like, my inclination was to do a match and to do it like this. Can you do like this? And say like I'm trying to think of how you do this. What number equal this? How would I turn a character from a number? I mean, I don't even know if this is right. So for now, let's just do this. Otherwise, continue or like what's going through my mind is I want to take the next character, and if it's a 0 through 7, I want to turn it into the actual 0 to 7 and make sure it's not in my list, right? Or like it hasn't been used yet in my password. And if it's not, then use it. So how do I turn this into a number? Feels like that's ugly, but we'll try it, and then we'll look for a better way to do it. But we try and turn it into a U size. If we do get one, can I do like if n greater than or equal to 0 and n less than or equal to 7? Oh, it's not and. And password n equals that. Like this is, I think it's something like this. Then we'll say password n equals results dot iter dot nth 6 dot unwrap. So we actually don't even need to do this. Oh, it's not iter, it's cars. Was it not saying? Oh, it's okay. Otherwise, we do nothing. Okay, why doesn't it like password to string? Does not implement display vec car. Like that. Oh, password's not mutable. What did I do there? It's probably saying I can just do this. Oh, this one will always be the case. It is not fast. Again, we can probably speed it up by doing the encoding trick. Ooh, we can technically, from this result, also get these, which may make it easier. Yeah, is most of my time going to be spent? Oh, I never break. That's dumb of me. So if we ever add one, we can then say if password dot iter dot filter c equals dot count equals 0 break. No. Okay, let's try that. I mean, it may still take a while, but hopefully not a million seconds like it is going. But that was definitely an error. I wasn't okay. Is that the new password? 5 seconds is still really slow, so we definitely have some optimizations to do. That's right. Okay. I mean, not too bad. There's definitely optimizations to do, so let's work on those. Yeah, so how would we optimize this? I mean, first of all, we can do the trick where we know like the first n bits and then the nibble or whatever they call it, like the first part of the next one start with a 0. Actually, what is this return? Yeah, like vec of bytes. So like the idea is this constitutes 2 zeros, this constitutes 2 zeros, and the first half of this one constitutes a 5th 0. So it'd be something along the lines of, I mean, I guess I'm done with the puzzle, so I don't mind using like you just have to do some anding. You do like a 1 shift flip or something like that. We'll ask it. How do I check if the first half of a Q8 is all zeros? Oh, it's even easier. Duh. That should be obvious. Okay. after looking at that, that feels super obvious, right? Is you just say, you just and it with that. And if it is, it's that case. So we can do this as an optimization, right? So instead of converting it to a hex and doing this, we can now just say if results 0 equals 0 and results 1 equals 0 and results 2 and 0x f0 equals 0. Is that right? So it'd be results. It'd be the lower half of this one. How would I do that? So like what it is the low, think of this as an F. I don't know what this is, but it's whatever this value is. So how would I do that? I want to or 0f. So it'd be like results to or 0x f0. No, 0f like this. Because I'm like, what this is has the effect of doing is turning off all of these and turning on just these. And that's going to give me a number. And now I need to turn that into a hex. I mean, let's ask ChatGPT. Hex equivalent character. Oh, it's not an and, it's an or. So I or it. And I do standard car from digit unwrap. Okay. So we can do that. Oh yeah, it wouldn't be oring, it would be anding. And OXOF. So I guess I don't need these then. No, I still might. So the question is, does that make it any faster? I mean, it did. I can't see. It was in like the 2 to 3 second range, and now it's in the 1 second range. So this definitely helps. So I can do the same logic down here. So we know we're at like 5 and somewhere in the order of 5.5 seconds. So I don't have to do this. That replaces that. And so we say the N is just going to be results to and OXOF. Like, because we want the actual digit number. Right? So we turn off all the digits but the first set. And if it's not like but it's going to be ASCII again. So I do have to... Like, what I mean is, what I want to do is turn this into a number. But, like, do I really want to turn it into a digit and a number? I don't think I do. I just want to do, like, let n equal... zero. I'm going to subtract this number from 0, so like it'll be like results 2 and 0x0f minus this number. So if it's any other character, yeah, so I can just do a match on here now, I think. Then I use this. But I want the third one, and I want this digit right here. And if they're all filled up, we break. Like that. Oh, do I have an extra one of these now? I think I want to still do this check because I don't want to like cast it to a 0 by accident. So I'll do it right here. That. Oh, because it's a U8. I think the problem is I could get like ABCs, like think about the ASCII table. Maybe I'm overthinking this. But like the characters I can get are these ones. Oh, these are always larger. Okay, so that's right. That is. So I can simplify this then. Because it may just be a really large number that's outside of my range, and then I would ignore it. Does that still give me the same thing? Ooh, it's not finding it. It should have found it by now. So what did I do wrong? if this is a 0 and this is a 0, and this, so that shouldn't have changed. So now I want to get this. So I add it together and do this. I turn it into a U size. If it's less than 7 and password n is not or is blank, then I do this. And I do this. Okay, I mean, I guess we ask ChatGPT again. I guess it's like the lower half as a number. Why does that really? Okay. I'm probably overthinking this again. $52. This one right here. I don't unwrap this. I feel like maybe it's the end of the day, and so I'm just not doing well with this. Shift 4. Okay, that does make it faster. Is that the right answer? EO5. Okay. Okay, so we have sped it up. I feel like I've spent a lot of time doing this, but I want to speed it up even more. So some of this stuff feels a little wonky. So just I need to understand this a little bit more. I mean, I've done bitwise arithmetic before. So why does this work automatically? Okay, this would okay, I see why this would work and why I was definitely overthinking about it. Like the hex number that's going to go right here in the 2-digit hex, if it's a digit 1 to 7, it's literally going to be a 1 2 3 4 5 6 7 or a 0, right? 0 through 7, I guess. It will literally be that. And so I just casted, I take the first, I take this lower half, I guess, cast it to a U size, make sure it's less than or equal to 7, and then that thing is in there and that works. Okay. This is a nice trick too. I like this, where we can say, okay, just check the front half, because I think we did a more complicated result later. So this makes more sense. Just it's like we should be using more bit logic for this type of thing, and then we don't have to actually convert it. This one is interesting. I had to think, well, this one makes sense. Let's look at this one though. We're getting the lower half as a U30, and then we do from digit. So why does that work? So from digit is going to give me, let's see what this says. Convert a digit in the given radix to a char. Okay, so that's what we're doing, is we're saying, I'm going to give you a number, you give me the equivalent in hex. That's what this is basically saying. And so how do I get that number? Well, I want to AND this, which has the effect of getting rid of the first half and only keeping the second half. So why didn't that work down here? Oh, I do need to shift. So I could do this and the F0 like I do, but I do need to shift, because so here's the problem, is that what I was doing before was this, but with the F and the O switched, this wouldn't have worked because it was still keeping the higher order bits turned on. And so the number was very large, if that makes sense. Which couldn't be turned into a hex. So you shift 4, and then it takes those higher order bits, moves them down to the lower order bits, and then you can do the conversion. Okay, so that speeds it up. Okay, I want to try and do the rayon thing to speed it up even more. So let's just ask and see what they say. I have to do MD5 on an incrementing value. I want to use rayon to speed it up, but I need to get the first 8 values that match some hex checks. How can I use rayon to do that? Parallel brute force pattern fire. Yeah, par-iter. This is not start plus chunk size into par-iter. This is trying to do all of them in parallel. So this is just doing it like blocks at a time. But doesn't Rayon have a... Let me see if I can find it. I know it didn't work when I tried to do it before, so I'm kind of interested in... let's see, what was that thing that I did in the previous one? By exponential blocks. So can I do this with that didn't work though when I did this. The catch is an unbounded range and it requires an finite range. It implements, so the above code won't compile. You'll get something like this. Manually simulate exponential blocks. Okay. I mean, I could try that. It's still this feels really slow. Maybe there's no way to do this. The reason it sounds like the reason why the other one worked is, and this kind of makes sense, is like the idea is the by exponential blocks is going to like start getting more and more things, and it's going to do like a find first, and so it has to do some logic, but it's hard for it to like serialize in order the values, if that makes sense. So how would we do that? So let moot cur equal to 0. Let mute block size equal to 1, 2, 4. Will loop forever. And then we will say let solution equal and then what are we going to do in here? We're going to say like oh, but this does have an end to it. So I am curious why this doesn't work. like we double it. So we do we're gonna filter map. Okay, that's a lot faster. Like, how fast can you make it? Probably a matter of like playing around with it. It doesn't look like it's any. What it sounds like is maybe the. No, that can't be the case. I was thinking like maybe this is a relatively small number. Like if you did 16,000 or whatever, I don't think it makes it any faster. Yeah, like it's all in the order, you know, so like you're going to do this that many times, and so maybe it helps. So we do this. I guess I don't need this because I already have the password. But we'll kind of move this one into the other one, I guess. So this, we're still going to do this. We're going to do the par iter collect car. So I actually think we want to move this loop. Right here. The break doesn't make sense though. So I think what I actually want to do is return like this. Otherwise, we return none. So now I'm going to collect. I actually think now I don't even check this. Oh, well, I definitely don't check this right here. Oh, I'm also missing an extra one of these. Like that. So we'll say wall password dot iter dot filter c equals so as long as that's not 0. What does it like about that? Oh, do I have to do this? Like that. So while we haven't filled up the password, we're going to do this. And so once we've gotten these, we'll say like for nc in found. We'll say if password n equals this, password n equals c. Like that. Oh, I have double equals there. Like that. Okay, much faster. And I do get the right answers. Okay. I mean, have I spent enough dorking around with this one? Probably. The several seconds is probably okay, but it felt really slow. So I'd definitely be interested to see, and we've spent as much time fiddling around as we have solving the 2 parts, it looks like. Is that right? Yeah. So anyway, I'll submit this as is. It's definitely faster. We're solving it in milliseconds now. This might be fun to look up. You'll how those like speed solvers solve something like this. Maybe this is one where they just struggle with because it has to be big. Maybe they have some cool way of doing it. That would be interesting to look up. So maybe we'll do that in the recap. I'll add that to my notes. But anyway, let me know how you did. Let me know what you think of these solutions. I definitely think these ones have room for improvements. So I would love to see how you solved it. I do feel like I've learned a lot from this one. I don't know. I used to use C all the time, but it's been a while. And you just don't do this kind of bit manipulation a lot. At least I don't in my work. So I'll have to, it might be worthwhile freshening up on these. I'm kind of interested in maybe trying to do this upcoming year competitively. And so I've been thinking as I'm doing it, like, what are some things I had to refresh on? And before I forget, I'll add it right now. I have like a little list of things I can. So graphs, Rayon MD5, path finding, and then byte stuff from 2016, day 5, right? Okay. Anyway, let me know what you have, and also if you have any ideas of like how you got into competitive programming. I saw there's a book about it that I bought, and so I'll read it and see how useful it is. But if you have any tips on doing it other than just practicing, that would be fun to hear too. So there you go. Thanks everybody for hanging out with me. We'll talk to you next time. Bye everyone.